Hello, everyone. Thank you for joining us today. I'm Yasmina Greco. I'm with O'Reilly Media, and I will be your host for today's webcast. Today, folks, we have quite the lineup of speakers for you. We have Jon Bruner, Kipp Bradford, and Rob Faludi with us today, and they are going to talk to you about getting started on the industrial internet. We are very excited to have these gentlemen with us today, folks, to present this webcast for you all. Okay, as we get started here, I would like to go over a little housekeeping to help you get the most out of today's webcast. You'll want to open your group chat widget if you haven't already done so. This is where we can interact with each other during the event and where you can post your questions for our speakers. We find that our audience usually has a lot of good knowledge to share, so we encourage you all to chat freely during the event. However, if you have questions for our speakers, please preface them with a capital letter Q so we know that it's for them and we can make sure they see it for Q&A. You can also open, move, and resize any of the other widgets. If you'd like to tweet from the Twitter widget today, you might need to give it permission to access your account. It will automatically append the event's hashtag to your tweet so you don't have to. And today, folks, our hashtag is Industrial Internet, all one word. If you should have any trouble during the event, please take a look at your help widget. If you continue to have trouble, just post it in the group chat and one of our staff will help you right away. For choppy audio or stalled visuals, try refreshing your window. And remember, the best thing you can do for a good audio stream is to close any apps that could interfere. People always ask, so we'd like you to know, we are recording today's webcast, and we'll have the archive ready usually within 48 hours. And folks, at this time, it is my pleasure to turn the program over to Jon for his introduction and his presentation. Hello, Jon.
Hello. Thank you so much, Yaz. And thank you all for joining us. I'm excited to see that there's so much interest in this topic, and I'm so grateful that all of you tolerated our hold music while you were waiting for the session to start. I saw that that was the most the topic of most interest on the back channel chat room. Today we'll be talking about the industrial internet, which is the subject of a research report that O'Reilly just published and that I wrote. You see the URL for it on the screen, and I'll also push it out to you as a link at the end of my part of this webcast session. The industrial internet is the term we're using for the coming together of intelligent software and big machines, sort of like an enterprise level Internet of Things. This has been around for a while. I mean, software on top of things like industrial controls and jet engines and whatever has been around for a long time. The important theme that we are excited about now is access. The way that we see the industrial internet moving along is analogous to a handful of developments in software over the last few decades that have made software broadly accessible and software easy for anyone to start writing and start developing and start applying to important problems. The first of these, if you look back, I'm trying to advance my slides here. There we go. The first of these, if you look back over the last few decades in advances in software, is abstraction. Here you see assembly language, which is the language of computer processors. This complicated block of language does nothing but display "Hello World" on the screen on some types of processors and operating systems. It is complicated language. It's language in the format of language in the way that a computer speaks. Its logic is that of a computer processor. It's difficult to learn. It's unintuitive. This, by contrast, is Python, and it's an abstracted, high-level language. It's taken the logic of a computer and made it human. You take anyone here, even without any knowledge of programming, can probably tell exactly what this code does, right? It adds 1 and 2 and prints the result 3 onto the screen. Abstraction has made it possible for just about anyone to learn how to how to make a computer do useful things, starting from scratch and building up from there. Similarly, the software has advanced and become accessible to the masses through modularity. R, for instance, the statistical programming language, has been around since the early 90s, and it has over 4,000 modules that you can add in and start using immediately without any particular expertise in the underlying technology of them. If you're an epidemiologist and you want to do epidemiological studies, but you don't know how to program epidemiological models into a statistical programming language, you can download the appropriate package from R and apply your expertise in the science of epidemiology, rather than developing expertise in programming in R. This has really taken off over the web with web services that become modular. For instance, most famously probably Google Maps, which makes it really easy to have very sophisticated maps on any kind of website, any kind of web service, without any expertise whatsoever in cartography. You can have your main interest be in cupcakes, yet it's possible to express your interest in cupcakes on a sophisticated map. These modules can fit together, multiple modules in the same application, and the way that they're typically built, loosely joined, they handle failure very gracefully. They have easy to understand programming interfaces that make it easy to tie them together. And so people without expertise in infrastructural computing and building apps from scratch are able to do really useful things with these kinds of modules and services. For instance, this live map of buses in San Francisco, which takes one web service module from Google and a web service module from San Francisco's public transit operator, and merges them together into something that anyone can understand. And it's pretty easy to build something like this without a lot of expertise in development techniques. What we're seeing now is a really exciting transformation where the same sorts of developments are coming to the world of hardware. We have things like Arduinos, which you see here on this slide, which are easy to program microcontrollers that anyone can really learn how to use in about a weekend. If you have any knowledge whatsoever of programming, you can take on projects that used to require the expertise of an electrical engineer and execute them in very little time. Scaling up from that, you have you see substantial machines starting to become open to people who aren't experts in the underlying complexity of these machines. Ford Motor, for instance, has created a platform called OpenXC, a software developer kit for the drivetrain network in its cars. These are the networks that have been in cars since the late 1980s that link all of the sensors and controllers in cars into a common bus, are now accessible with an open source hardware interface to an Android phone that you can use to read anything like steering wheel position, fuel air mixture, automatic transmission, gear, things like that. Hundreds of different data streams available now to your phone. You can imagine that when something like this, so it's read-only right now, which means that you can develop an app that maybe coaches a driver on how to save gasoline by saying, hey, you're accelerating a little too fast, you should accelerate a bit slower. But you can imagine that someday apps like this will have write access to the big machines that they're attached to as well, and thus make operating these machines highly accessible to anyone who can develop a mobile app. You could imagine that in 10 years you would plug your phone into your car, and if you want to If you want to save fuel, you could load an app that's oriented to that would change the fuel-air mixture in your engine, change the shift points in your transmission, maybe blunt your acceleration a little bit. Or if you want a sporty drive, you could download an app that would do that and change the operation of your car as well. So this is making the operation of these big, complicated machines accessible to people whose real expertise is in software development or data analysis or optimization or things like that. Someone who knows about statistical models for things like e-commerce might have a great deal to add to the way that we operate the world around us. At the very most complex level, we have things like the Boeing 787, Boeing's newest commercial airliner, which uses a pretty standard sort of network connection to connect all of the electronic and mechanical systems on the airplane. It's very similar to Ethernet, actually. You have IP-addressed jet engines on these airplanes, everything linked together in very robust and flexible ways. The 787 can, in normal usage, generate as much as a gigabyte of machine data per hour in the course of flight that can be used afterwards, after the flight lands, to improve training of the pilots, detect maintenance needs in the aircraft, or develop future algorithms, optimization algorithms that might improve the autopilot on the airplane or something like that. In short, the industrial internet presents itself as something of a spectrum. And this graphic that you see here is a draft, sort of brainstorming graphic, so don't read too much into it. But the way I'm thinking about the industrial internet is as this spectrum of accessibility from, on the left, things that you can get into in the course of just a weekend. Very easy to get into. The maker movement, the sort of hardware, home-baked hardware, home-baked machinery enthusiast movement has exploded in popularity over the last few years. It doesn't take much to invent little sensor devices and sort of connected machines that quantify aspects of your life and bring you into sort of the quantified self movement, help you understand the things that you do, your health, your work habits, and so forth. It's easy to, for instance, use an Arduino to build a building control system that turns your living room lights off from a command on your smartphone remotely. On the far right, you have a lot of very heavy-duty sort of hardcore engineering applications, things like electrical distribution, industrial controls, where it's very important to the buyers of these systems that their systems come from reliable engineering-oriented organizations, and those will, I think, some of those areas will continue to stick with that kind of firm for a while. But in the middle, there's this vast, accessible area where the physical world and the software world are meeting and overlapping in very exciting ways. This doesn't mean that Boeing will someday publish an open software developer platform for its aircraft and invite individual sort of enthusiasts to create apps to change the way that an airplane works. But what it does mean is that companies like Google and Amazon and Microsoft and Yahoo that have developed very serious expertise in certain kinds of optimization methods, software techniques, computing processes will have a lot to add to these, to even the most sophisticated projects on the industrial internet spectrum. Consider, for instance, that the current leader in driverless cars is Google, which is not a car company, it's a software company, but it's managed to take the problem of building a driverless car and abstract it into a software problem, which is the sort of problem that Google is very good at solving. They've abstracted it into a machine learning problem, and they have solved it that way. So the software community has a great deal to add to this area of the industrial internet, and we also think that the engineering community has a lot to gain from collaborating with the software industry, and a lot to tell the software industry about its needs and how the two can work together. We at O'Reilly are very excited about this area because it presents opportunities for the sort of software mindset, the innovative entrepreneurial approach to come to the physical world and solve really important problems, address things like energy conservation, fuel economy, competitiveness of the manufacturing industry in the developed world, making our world much safer and more convenient, more responsive to people, and just help it operate much better altogether. So I hope you'll join us at O'Reilly as we investigate this area and help bring the software community and the engineering community together to collaborate. I encourage you to take a look at the report that we came out with last month. I'm going to send you all this URL here where you can download the report for free. It's also available from Amazon.com for Kindle and from Google Books and iTunes, all for free on your favorite reading device. There are a lot of case studies here and some ideas about how the software and industry and heavy industry will collaborate and do really interesting things together. So I have a couple of other speakers with me today who each bring their own perspectives to this broad area of software and the physical world coming together. Next up we have Kipp Bradford, who is a professor at Brown and is also an expert on building on the frictionless framework for manufacturing. Before we go to Kipp, I'm told that I have a question here from Ricardo. What do you think of Raspberry Pi regarding our topic? I think Raspberry Pi is a really intriguing device. I have two of them myself. I'm using one to display upcoming subway trains at my nearby station, and I'm using one to measure the odd behavior that my cat sometimes demonstrates. Obviously, there are much more serious things that you can do with it, and it's incredibly promising that you can have such computational power in a small and sort of distributed and inexpensive framework. So I think we can come back to this in our longer question after Kipp and Rob speak. But I think the Raspberry Pi is a terrific device, and what we'll see is sort of a continuum of intelligence that goes all the way from local intelligence, a computer mounted on the side of a machine, all the way up to the cloud, and a lot of intelligence in between as well. Thank you, Ricardo, for your question. And now I will turn the call over to Kipp, who will talk to us about manufacturing and his approach to this broad question of software and the physical world coming together. Kipp.
Thank you, John. Your introduction is fantastic, and you've set me up very, very nicely for, I think, a interesting look at one thing that you mentioned, which is access. So part of why this is a very interesting conversation to me comes out of the book that I just wrote for O'Reilly, and I'll drop the URL into the chat for that. And I'm not doing this to promote the book, but I do want people to be aware that there's some resources available through O'Reilly that help look at what I'm about to talk about. So the idea of access that John mentioned is a very important idea, and it's an idea that embodies why the conversation about the industrial internet is extremely timely and extremely important, and why it's something that all of you watching this webcast now and listening to it can get involved and engage with. And there's a transformation taking place or disruption taking place in the world of the industrial internet. And it used to be that the industrial internet was like the mainframe world, where the tools and technologies and resources were controlled by large corporations that had the money and the infrastructure to implement these complex, sophisticated systems that required teams of engineers and developers to set up and maintain. As we saw with the world of mainframes, as thinkers and hobbyists and innovators got involved, they said, you know what, we want this kind of power to be in our own hands and want it accessible to us to apply to the problems that we see and that we deal with. So what had been the domain, solely the domain of big companies, could then be done at the scale of the individual sitting at their home. And with the industrial internet, what's pretty interesting is that that same transformation is taking place, where once these tools were only available and accessible to the few, and now we see a great democratization of these tools and technologies, so that the individual at home can purchase an Arduino and can implement something that collects data from machines, lets you aggregate that data, analyze it, and take action based on that data. So I want to take a look at two concepts that really make that possible and explore a little bit more deeply what Jon was talking about. The idea of abstraction and modularity, I think, are really critical elements to why this is more possible today than it was 20 years ago. Arduino takes the modularity methodology and brings it to a place where it's, on the one hand, Arduino is nothing new. We've seen chips with motherboards and daughter cards in the past, but Arduino has done this in a way that I think, number one, it's inexpensive. You can go down to a Radio Shack or go to the Maker Shed or SparkFun and order an Arduino for very little money. The tools and tool chain are very inexpensive. But number two, Arduino has really focused on this model of modularity. So the Arduino itself is meant to be plugged into application-specific daughter cards that are known as shields. And a significant number of third-party shield designers and manufacturers like Adafruit, SparkFun, et cetera, have popped up and created essentially a shield for every purpose. At Google I/O in several weeks, my team with the data sensing lab that's part of the that Rob might mention in his talk, we're deploying 500 sensor motes that all are Arduinos plus an Arduino Shield, and the Arduino Shield has a number of environmental sensors that collect data and put data up into the cloud. So the Arduino model has nailed this idea of complete modular hardware. It's also really captured the idea of modular software, where anytime I start an application with the Arduino, I start by grabbing sample code or open source shared code online and download that into the Arduino and use that as a starting point for whatever project I'm developing. So modularity is very important. Arduino is one example of that. There are many more examples. Where I think we really have to focus, though, as Jon mentioned, is the abstraction. The abstraction does something that allows people to focus on their domains of expertise. And what I mean by that is that previously, in implementing an industrial internet, the implementer needed to be a domain expert. So if you were trying to network the machines in your factory, you had to be an expert on all of those machines, but then you had to develop a significant amount of expertise in the tool chain that you're using to actually create that industrial automation and create that industrial network. So not only did you have to learn LabVIEW and all of the LabVIEW hardware and how to hook up that LabVIEW hardware, but you had to know your shop floor, you had to know the machines, you had to know your business practices. It was rare to find an individual that had both of those domain expertise. So typically that required hiring a consulting firm to come in and add the secondary domain expertise, which is an inefficient process. It's a friction point in the implementation of the industrial internet. As the tool chains have become better at abstracting the tool chain expertise out, as Jon mentioned, now we can focus on the domain expertise. So a domain expert can bring in tools that are very easy to use, very easy to deploy, and focus on the domain problem of creating that industrial internet for their particular domain, particular application. So what we essentially see is that the fixed costs of implementing these new industrial internet tools, that fixed cost has been reduced significantly and encapsulated in the expertise that's built into these abstraction layers. Again, for a very simple, inexpensive example of that, Arduino, I think, does it perfectly. All of that low-level hardware stuff, the assembly language, even a lot of the C-level programming that would normally take place, like register configuration and processor configuration, has been encapsulated in the expertise that's built into the modular abstractions that Arduino uses. So I think having that the complexity so nicely encapsulated really allows the domain experts to focus on the main problem they're trying to solve rather than having to additionally become toolchain experts. I want to highlight a couple examples. I think Jon's paper does a really, really good job of presenting some case studies, and one of them that is particularly interesting to me that I've had some expertise with is the area of smart grids. There's a company called VCharge Energy, and I'll drop their URL that I think is an interesting company to take a look at, because they're really one of the companies that's on the forefront of, number one, abstracting out the complexities of the industrial internet, and number two, providing value to customers at both ends of that data. So what I mean by that is that if you look at the smart grid, there are two stakeholders. There's the power producer, or really the transportation, distribution, generation side of the equation, and then there's the end user side of the equation. And essentially, we have end users who want to save money, namely the electrical customer, and we have the supply side that would also like to save money. So you have supply and demand. Both are looking for increased efficiencies in the delivery and usage of their services. Traditionally, grid balancing used to take place at the supply side, where a bunch of people turned on their air conditioners, turned on the heaters, whatever it was, and I would have to be very sophisticated at predicting those demands. When you look at the electrical grid, there's a fixed pipe electricity is going through, and that fixed pipe, every electron that you put into the electrical grid has to come out the other end. And if there's an imbalance of more than a handful of electrons, the grid starts to flake out, brownouts, blackouts, full failures. So there are a number of players in the grid who are controlling the supply and the demand so that you have that perfect balance of electrons in and electrons out. Today, the big machines on the electrical grid are on the supply side. So we have generation, and we have what the independent service operators, known as ISOs, are doing at trying to route and manage those electrons. And when they see a dip in supply, they tell the generators to turn off their generation. When they see a boost, increase in demand, they will tell those generators to, they'll call in more power to the grid. In the very near future, as more wind and solar energy is put onto the grid, that becomes increasingly difficult. It's very hard to tell the sun to go up or down in the amount of energy it's sending to the earth. It was much easier to tell a generator to spin up or slow down generation. If a cloud passes by your solar panel, you have to do something at the other end to make sure that the grid doesn't fail under those changes in supply. So what we really see is a need for demand-side regulation. And today, with all of the dumb appliances out there, that's not possible. But once appliances start to become smarter, you have the ability to do some very, very cool things, which is machine-to-machine communication. A generator can say to a social network of appliances, hey, is there anyone out there who's willing to shut off so that I don't have to spin up immediately because a cloud just passed over me and I don't have as much power, as many electrons available. And a bunch of air conditioners, refrigerators, washing machines, and dryers can respond, hey, yeah, I'm willing to turn off for this price, or I'm willing to turn off for that price. And you have a nice little bidding system where those appliances can turn off in order of the lowest bidder for the cost of those services to regulate the demand. So very interesting possibilities available in the near future. And there are some examples of companies that are actually doing that today. And what that offers for the end user is the ability to save costs on bills. If I'm willing to let my air conditioner, my refrigerator, my washer and dryer turn off, I can sell that ability back to the generator who's willing to pay for it because they are not able to ramp up their electricity. So I'm happy to take some questions. I'm just going to close with my colleague Alistair Allen and I tried and hopefully succeeded to put together a book that brings first-time users through the process of building a network-enabled sensor system from start to finish. So everything from how to use the Arduino to how to use Python to see your data and communicate with your sensor, to implementing a very, very basic sensor network, to visualizing your data with Python or LabVIEW. And hopefully that will be something that some of you will find useful as you embark on your first projects to build the industrial internet into your products. Thank you, and I'm going to pass the microphone off to Rob Faludi, who will hopefully tell everyone more about the industrial internet from his perspective at Digi. Rob, you there?
I am indeed here, and my name, as Kipp said, thank you very much, and thank you guys both for your great coverage of how the Internet of Things and the industrial internet are really coming together as a connection between this robust maker, what I think of as the innovator community, and business. I work with the innovator community quite a bit. My main day job is for Digi International. Digi makes, among many things, the XB radio that some of you are probably familiar with. But we also make a complete end-to-end solution for machine-to-machine communication in business, what's called M2M, also called the Internet of Things, also the industrial internet. And what I want to talk about today is how the Internet of Things is really going to reshape business. I guess my own take on it. Both Jon and Kipp have covered their take as well. So I'd like to get started. There we go. By just briefly mentioning what businesses have out in the world. Businesses have assets that belong to them, and they can be things that they own that are very expensive, such as freight chains or, as Jon described, airliners. But they can also be things that they made, which have then been sold to end users, small things like microwave ovens. What those two ends of the spectrum have in common is that businesses have a problem. And their problem is that they can't see all the stuff that's out in the world. It's not like in the old days where the factory manager could get up in their office and look out a window and see everything going on in their business right down there on the factory floor. Right now, business operations are far-flung. They are global. But that creates a problem because businesses thrive on rich interactions, not just between individuals within the business, within the organization, but also with all the devices, assets, and products that are out in the world. And what they need is visibility to see what those things are doing and ideally control of those assets so they can make changes that respond to events that have happened out in the field. Interactions with these devices plus visibility to know what they're doing create something wonderful, which we call situational awareness, getting the big picture. So that's really the dream. The power of the industrial internet is really to provide this sort of situational awareness and control. So it's a great thing, and we're all very excited about it. And you might wonder what took so long for this to happen, and why is it happening now? And my opinion is that it is four things have kind of come together: cost, connectivity, carriers, and comprehension. I'll break that down. Things are not like software. Things cost money. Software, you want to make 2 copies, you want to make 1 million copies, you can accomplish that without any real material cost. But objects and radios and networking are different. They have to be mined, refined, transported, constructed, tested, shipped, delivered. Because of that, they have to provide tangible benefits because they're going to cost money to start with. You've got to have a return on investment with things. And the electronics that are involved in M2M device networking for industrial internet are now reaching this kind of critical value point where as the cost of implementing these systems starts to go down, the value of the systems and their implementation is going up. The 3 other things are connectivity, carriers, and comprehension. Connectivity is really just means the internet to us now, and that's become available almost everywhere on the globe, that you can see the sky through satellites, but much more commonly through wireless providers and internet backbone providers to locations all over the place. Carriers are another important player in this game. They need a new market to grow. For a while, carriers could depend on mobile phones being a huge market. Well, that's starting to get saturated, and now they're looking for new ways to provide value. The last part is comprehension, understanding what connected stuff can really do. And, well, that's why you're all here on this webinar. You're trying to increase your comprehension, and hopefully we're helping. But that comprehension about connected stuff is even reaching all the way out to consumers now with things like the fuel band and various other devices that are bringing intelligence and interactivity into objects that we find in everyday use. So consumers and businesses are both understanding the value of the Internet of Things, but they're different. Consumers are driven by perceived benefits. They're looking for things in the objects and devices that surround them, like entertainment, convenience. They maybe want to turn their air conditioner on and off while they're in another room. Personal safety, knowing through GPS where their children or pets are. And they, of course, make purchases one by one. If you're selling to consumers and you sell them a thing, well, that sale is done, and now you need to sell them another one thing. And they have to be addressed one at a time. Businesses, on the other hand, need concrete benefits. The real commercial drivers are going to be 3 fundamental things. Improving an existing revenue stream. For example, let's say you're a vending machine manufacturer, and sometimes your machines break down and sometimes they run out of supplies. Well, if you can get better visibility and situational awareness around that, you can address it, and when someone goes to buy a bag of potato chips, that bag of potato chips will actually be there for them to buy, and your ability to make money will increase. You also have the ability to create new revenue. Let's say you're a hot tub spa manufacturer and you want to create a service where you guarantee to homeowners and hotels that that spa will always have the chemicals that it needs. Well, if you can get visibility into how those chemicals are actually being expended, then you can provide that whole new service, the guaranteed spot, and that's new revenue. And finally, by doing either of these things, you will enhance the user experience with your products. You're going to make it better for people using your things, for the people managing your things, whether it's on a consumer or industrial scale. That's going to create more happiness and hopefully improve your business as well. Finally, purchases made by businesses are made in giant multiples. So you don't sell just one thing to the vending machine company. You are going to sell them things for their 20,000 vending units. So there's really a rich, rich market out there. The adoption path, here's how I see it. The first wave, and that's already begun, and John has talked about that a lot, is these kind of large remote assets like airliners, where by putting in a connection, you're going to get an immediate return on investment because you'll be able to have up-to-the-minute information on what parts a jet engine needs on maybe a $300 or $400 million aircraft. So that first wave is already well underway. My company, Digi International, is doing the same thing in markets like positive train control, knowing where a freight train is and its health. Those assets are expensive enough that it almost doesn't matter how much it costs to plug them in because you're going to get a benefit out of it. But with other assets, it really does make a difference how much it costs to plug it in. This is sort of the second wave. There are these moderate-sized assets where you will get a return on investment, and that is being enabled by cost reduction. That might be something like vending machines. It might be something as simple as a gas station air pump. That's a real thing that we do. Understanding how much money is in the gas station air pump, you put these little quarters in, and somebody actually has to drive a truck around and take the quarters out. Well, you want to optimize the routes. You don't want them going to visit the machine if it only has 2 quarters in it and spending more on gas than they're making. At the same time, you don't want it to fill all the way up and break down. So by getting the costs of industrial internet down, you're able to provide a return on investment by connecting up these valuable business assets. And then finally, the third wave, I think, is everything else. It's all the products in the field. And to a large degree, this is still to come. But I believe it's going to become a competitive necessity. And here's the reason why. When you go online and do a search, let's say on Google, maybe you like Bing, or maybe you go on Netflix to buy a movie, they know everything about your activity. It's all kept in a log file. So what you searched for, when you searched, maybe some demographic information about you, who you are, and how that changed over time, how one search maybe relates to another search. Google knows all that. But if you buy a microwave oven, here's what Whirlpool knows about the microwave oven you bought. They're down one microwave oven out of inventory. And if you don't send that little warranty card in, that's the last they ever hear about it. But that's not ideal. Whirlpool would love to know everything about that microwave oven. Why wouldn't they? They'd like to know the location, how it's being used, if there's a service opportunity. How is it performing? How are you using the features? What are the user's preferences? All that sort of information would be incredibly valuable. And at the same time, it opens up an opportunity for doing the type of testing that online companies can do. Let's say as a microwave manufacturer, you want to know which interface is working best on a microwave. Well, you can do the same sort of A/B testing, comparison testing, that Netflix can do, changing the interface for 2 different users and seeing which one works better, how that changes behaviors. With a connection into the device to make those changes and upgrades and information flowing back out of it, you arrive in a very powerful spot as a manufacturer. Now, you might be thinking, well, that's great, but why would I want a large industrial company up inside my microwave? And I think the answer there is that the companies doing this really have to make sure they provide value to the end consumer, the end user. The value in the case of the microwave is making the microwave work better so that your popcorn never is burned. It always comes out beautifully. The value right now, I think, that businesses are looking for are those 3 major cases: creating new revenue, getting improvements in their existing revenue streams, and creating a better user experience. But in the future, I believe that every device is going to provide this sort of rich ethnographic information about how it's being used, what it's doing, and allow manufacturers to make dynamic improvements to the operations of devices, whether they're a giant aircraft or maybe even something as small as a blender. It'll allow for the kind of fast iteration and just-in-time incentives that a company like Google can provide in a software interface. And that is where I see the future going. I believe that businesses are going to have to eventually connect their devices in order to remain competitive. At Digi, we're thinking about that both through the wireless networking and wired networking devices that we make, but also really as a complete end-to-end system of solutions that, and it's interesting that Jon mentioned the Google driverless car being abstracted into a software problem, because with our Ethereos device cloud, we are doing the same thing. We are trying to take all this machine information and abstract that really as a software problem so that it can be addressed in software. And I'm happy to take any questions that you might have about where we think that is going. Thanks a lot. So I'll go ahead and hand this back over, I believe, to Jon, who can take it from there. But thank you very much.
Great. Thank you so much, Rob, and thank you also, Kipp. Those were terrific presentations. We have a number of questions that have come in from audience members who have joined us, and since we have about 15 minutes to get to them, I'm going to sort of cluster them together into slightly more general questions, and we can open them up for discussion. The first cluster of questions that I've seen has to do with security and safety on the industrial internet, which are two slightly separate questions, but they have similar answers. So by security, I mean malicious programmers who try to hijack sort of physical world systems in the way that people commonly do in information systems, and also safety. For instance, why are we letting amateurs who are writing software in their basement, affect the way that my car drives? So, point number one, I think, is that in terms of security, the worst situation that you can be in is to think that your system is not connected. Every system now is de facto connected, and the owners of systems that realize that their systems are connected and implement security systems that take that into account are way better off than the ones who think that they're maintaining a separate system. If you think of Stuxnet, for instance, which is the most famous instance of security breach in the industrial internet, that malware actually crossed an air gap using printer servers and thumb drives within the Iranian nuclear agency. So it's not at all a sure thing that an air gap protects you. Instead, you should assume that you're connected and account for it. In terms of also, the security, malware detection, intrusion detection, and so forth is a little different in industrial and physical machine settings, because they often lend themselves pretty well, actually, to mechanized, to automated security methods like anomaly detection and pattern recognition, because M2M communications tend to be highly routinized and follow common patterns. In terms of both security and safety, I hope I didn't sound too informal in my presentation about who will be building some of the apps that control the physical world. With APIs, API providers have in the last few years found ways to provide interfaces to their services that both very effectively reject attempts at malicious connections and very effectively control access to different features of services. You can imagine that an application, an API for a car might have different write permissions for the entertainment system and for the drivetrain, so that it's easy to develop an app that brings internet radio into your car stereo and there's a bit more of a certification process and a maintenance process for apps that are able to write, so to speak, to the drivetrain. I think we'll see an extension of that. Actually, before I go on to the next questions, we have two extremely quick sort of flash polls here. I'm going to push the first one out to the audience, and we'd love to have you just check all of the boxes that apply to you. We're curious about who's joining us today, and we can tailor our answers a little bit depending on who you are. In the meantime, I'll pass the microphone to Rob for a second to address the security issue as well.
Thanks, John. I wanted to add, and the points you make are excellent, that making sure that devices cannot accept certain commands that are detrimental to them is going to be one of the places that we're going to focus on security. And you're absolutely right. No one should assume a device is disconnected, even if you have the proverbial air gap, the thing's not plugged into the internet. Well, people can still walk around with USB drives and create security systems situations that way. But what I wanted to add on to that concept is there's a flip side to all of this, which is not talked about a lot, which is that by connecting a device to the internet, you actually gain a lot of security as well. There's a bit of a trade-off. Obviously, once it's connected to the internet, you have to think about making sure that the device has restrictions on it, that you're doing security the right way. But you're also gaining information about how that device is doing, where it is, what its supply levels are. And that creates a security situation. I mentioned the gas station air pumps. Well, the company that is now connecting to all those gas station air pumps now has a level of security that they've never had before on the devices. They know how much money's in them. They can tell things about shrinkage. Companies that do ATM machines sometimes plant little GPS radios in them, so if the ATM machine, if you wrap a chain around it and haul it away on your pickup truck, it'll keep reporting where it is. So security is there are two sides to the coin, and it's important that we remember both sides when we think about this. Taking a device and leaving it out in the field is certainly not the most secure thing you can do to it. And keeping that in mind will help you understand why this Internet of Things, this industrial Internet, is going to continue growing, despite, admittedly, certain risks that we'll have to come to understand better and better as we go by.
Great, thank you, Rob. I have just that's another important issue here. I mean, the industrial internet and connections can make things more secure in ways that are different from the ways in which they present possible vulnerabilities. And so it's
John,
important to balance these.
If I can
Sure,
throw a couple comments in on security also. One of the questions that I saw from Richard was, isn't there a major privacy and security concern with appliances sending usage information? This I sat in for several months on smart grid committees when I was involved with a smart grid energy company, and this is a question that lots of people had asked. And my reaction to that is that right now, if you want if you're a potential burglar or you want to see if a house is vacant, you can case the house, you can sit in your car and see if people are going in and out. The idea that somehow we're increasing that lack of security or we're making that security situation worse by making the data available digitally, I think belies the fact that the most common way for burglars to know that a house is vacant is to actually sit and look at the house. What's interesting in that case is that now if your appliances are hooked up and available on the internet, you could have an away program where all of the lights have random turn off times, various appliances simulate various loads so that it appears that the house is actually more active than it would be today. So I think while, yes, there's certainly some concerns, there are also some opportunities to take advantage of these technologies to reduce some of the problems that we see. And I think that also looking at what opportunities we have to make some of these networks work for us instead of working against us. I think Earl had asked a question earlier about the amount of data that we're putting out there. Doesn't that open up the opportunity for exploits? And like Enron style, I think, again, the more the data is transparent and the more the data is widely available, the harder it is for somebody to control that data and exploit it for malicious aims. So if the data is visible by multiple people for analysis, that's where we can make sure that it's not used maliciously. I remember with Enron, there was an analyst at Forbes Magazine who was trying to understand Enron's data and said, there's a bunch of stuff missing here that I can't figure out. So the first time somebody really started to look closely and really start to dig, they said, wait a second, there's no transparency here, and the numbers don't make sense. So that situation, I think, the likelihood would have been reduced if there were more people who were looking closely saying, what's going on here, and how are they making money, what are those business models? So I absolutely think that there's some concerns, but I also think that there's some great opportunities for making these systems work better as we move forward and implement them.
Excellent. Thank you, Kipp. By the way, I've published the results of our first poll to you a few minutes ago, and the second poll, quick poll, is up now. I'll put the results up in just a moment. It looks like a lot of you are coming at this from the software side, though we have a few people joining us from the industrial engineering side. We see this as an area where the two disciplines converge, and each brings a lot to the table in the way of expertise and innovation and outlook. I'm going to publish the review of the second poll right now, so click one of the answers if you haven't already. Here come the results. Now we have another handful of questions waiting for us that I'm going to hand over to Kipp and Rob, sort of generally about what are the protocols that are emerging now for robust machine-to-machine communication, and sort of what should people aim to start learning in that area, both wirelessly and wired.
This is Kipp again. I'll tackle the beginnings of that, and I think I want to hand it over to Rob for some more in-depth coverage. But there's a lot of hardware out there right now, and a lot of hardware communication protocols like the CAN bus, actual industrial Ethernet that are emerging standards or have been standardized upon for machine-to-machine communication. There are software tools like LabVIEW. There's SCADA tools. There's a lot of existing hardware and hardware protocols. I think what's really changing are open APIs and open software protocols. Those are new and emerging standards as more people get involved, and a number of different sorts of systems are brought to the industrial internet. I think one of the challenges is that as each domain is different, for example, the kinds of communication you want for windmills talking to, or windmills or solar panels talking to your appliances is going to be a very different kind of communication than you want for a milling machine talking to a conveyor belt, or a jet engine talking to airlines and elevators on an airplane. The hardware might be the same, the buses might be the same, but I think the protocol layers end up being somewhat more application specific. And I think that's one of the interesting challenges. Is there a way to homogenize those communication protocols and the application layers so that there's some easy-to-use standard? I'm not sure what the answer to that is, because I think that each domain has some pretty specific security and safety needs, for one, but really just application needs that might drive different aspects of a protocol. That said, there might be opportunities to create a highest level topology and almost pedagogy for how you create protocols, so there's some consistency and intercommunication ability.
Excellent.
Okay, I just wanted to tag on to that. Yeah, there are, from the device level up, you have things like CAN bus and Modbus that, unless you are an embedded engineer, I don't think most people probably have worked with. But that is the language of devices. And so there's this process of translation from what the device is speaking now, and there may be new ones in the future. You are maybe familiar with onboard data 2, OBD2, which is in your car, that thing you can plug into your car. Well, there's a whole language canvas behind that. Translating those protocols up towards wireless protocols like mobile data communications, Zigbee, which I work a lot in, 6LoWPAN, which gives your device an IP address, Wi-Fi, however it's done, and then gatewaying that onto regular backbone channels, the regular internet, going through satellites is another protocol. And then abstracting that into software and presenting it in the kind of the modern way of presenting data, usually through an API, maybe using something like WebSockets. All of those protocols are going to be used. There may be new ones, but we should pay a lot of attention, especially on the business internet, to the older ones because we're going to be with them for a long time. They do great things.
Excellent. Thank you, Rob. A final question, sort of broad question that I'd like to move to that's related to a few that we've gotten from the audience. Let's talk about some companies that are doing interesting things with the industrial internet. Either of you is welcome to start, or I can mention a few.
This is Kipp again. I think VCharge is a company that's doing some pretty interesting things with the industrial internet on the energy side, as I've been watching them evolve, just as they're colleagues of mine that started, and they had taken very, very intimately to Zigbee communications and machine-to-machine communications between the ISOs that set electricity prices and appliances. I think National Instruments and LabVIEW is a company that is worth understanding because they've basically been automating machines for the last 30 years, and they're quietly in the background of these technologies. There's nothing that's really open source out there about what they do, but I think there are technologies emerging like Arduino that counter some of the issues with LabVIEW, which is with Arduino, you get millions of test cases, people using Arduinos in a bunch of different applications, so we can kind of aggregate the use cases and what works and what doesn't work, whereas LabVIEW, they've got great engineers at National Instruments working on specific applications, but I personally have had experience where I've tried to implement a very new product of theirs and end up becoming a beta tester at very, very time-critical and money-critical points in a project. So there's some interesting examples out there that exist currently. I think SCADA technologies have been around for a while. A lot of those mature technologies have great potential to be connected to the internet, and we have to worry less about the newness of the technology itself and worry more about what does it mean to actually connect something to the internet and allow devices to communicate with each other.
Great, thank you, Kipp. Rob, who's exciting you these days?
Well, there's two partnerships. One is one my company has, and another is not related. I'll start with the unrelated one, which is one that's always fascinated me when I learned about it, or really learned about why it existed a few years back, is OnStar. Now, you may know OnStar from a consumer basis. It's something that you would find in a car, and if you have an accident or press a button, you can kind of communicate with the home-based control center. They might know your airbags went off, or you could ask them for directions, that sort of thing. But the real value to OnStar, and I'm told OnStar is a billion-dollar business, is the fact that it is gathering information about the vehicle itself, passing that up the chain to the company that made it, typically GM, but it's not only GM, and then taking that information and pushing it out to GM's supply chain. So the power of that is that if, let's say, fuel pumps are wearing a little faster or slower than expected, all of that information suddenly becomes visible, and you can order more or fewer fuel pumps as needed, which means that your driving is actually affecting factory production in other countries. I think this is a very powerful model. The second partnership is one between my company, Vigi International, and a company called Salesforce. We just announced a item called the Social Machine. And the Social Machine is a plug-in for Salesforce, which is a customer relationship management software that many large companies use, to actually get machine information into the Salesforce channel. The idea being that now, instead of just knowing what all the people in your company are doing and how your sales are going and sharing that information, the machines themselves become part of that conversation. And I think that's going to open up whole new worlds of capabilities. And I think both are really very exciting things.
Great. Thanks, Rob. I would add to this that, involvement in the industrial internet takes a handful of different forms. And we see, every industrial company really that builds machines of any sophistication is investing a lot in the software that goes on top of the machines. The software in an airliner or a power plant that's built new today is very sophisticated, and there's a lot of thought given to the M2M communication going on there. A handful of big industrial companies are also laying out platforms to invite developers to get involved. That includes Ford Motor, as I mentioned earlier, and also GE, which sponsored our Industrial Internet Report and has really issued a call to the software industry to participate in its products. They've opened a big office out in the Bay Area. But this is a really wide spectrum of involvement. So you have the big industrial companies that have been building big machines for a long time are putting more and more software on top of them and carefully inviting outsiders to participate in their platforms. In sort of the mid-level, you have companies like Google that are coming at the industrial space with a very software-minded orientation. And then at the small end, at the startup end, there are a lot of really clever new companies. Sight Machine, which I mentioned in my research report, and Industrial Perception both come to mind. Both are companies that are taking computer vision and bringing them into industrial settings to do functions that previously were done sort of imperfectly by humans or very expensively by industrial machinery and industrial software. So it's a pretty broad spectrum of participation going on, and a lot of companies doing interesting things. I mentioned a few in the report, which again you can download for free on Amazon, Google Books, iTunes, and at O'Reilly at the link that you see on your screen. We are a little over time, and so I'm going to bring our conversation to a close. It's been fantastic to have such incredible interest from our audience in this presentation. We're looking forward to continuing the conversation, and thank you again to Kipp and Rob for your excellent remarks. You really brought a fantastic breadth of perspective to this presentation.
Thanks, Rob.
Those of you in our audience who have joined us, I hope you'll take a moment to fill out a brief survey. You see the link on your screen. This is completely optional, but it'll help us better understand the backgrounds of the people who are interested in this area help us better plan our involvement in the area and figure out how we might reach you and give you the information that you would like out of it. So, even if you only answer just a few of the questions on that survey, it would be very helpful to us. But thank you again, Rob and Kipp, and to all of those who joined us.
Thank you very much, John, and thank you for the audience for joining us.
All right. Thank you all. Take care.
Bye-bye.
Bye.